All right, good to go. All right, cool. Yeah, so as Rob said, my name is Whyiat Pauley, and I'm originally from Washington State. My dad was military, so I definitely lived around the country a fair amount. But as I went through high school, I made a transfer about sophomore year from wanting to be a marine biologist, realized that that is not a very good career option, and then I found out that I had a passion for engineering. So I went ahead and set me on the path to where I am now. At that point, I switched where I was wanting to go for colleges just based on engineering programs, and Cal Poly quickly became the #1 choice for me. Just as just the community here, just the Christian presence through crew and other clubs on campus, just definitely made it feel like I was more welcome and at home. It just felt right. So I originally, when I came to Cal Poly, applied to be a mechanical engineer because I had a broad, diverse field of interests. I wanted to maybe work with powered exoskeletons. I was interested in working with jet engines. I was interested in working with nuclear energy technologies, whether that be fission or fusion. I wasn't quite sure, so I chose mechanical engineering because mechanical engineering gives you the option that if it has a moving part, you can probably find a way to work on it. So incoming in freshman year, I was able to go through some of the orientation classes that Cal Poly offers, just giving you kind of an intro on, what is ME, what is all that's in this field. And by the end of that quarter, I had kind of decided I wanted to go towards nuclear energy. With that decision, I went ahead and with my credit space, because I did the Running Start program in Washington State, where my junior, senior year of high school went full-time to community college. And with that, I graduated with my engineering and physics transfer AA, as well as my high school diploma through the state. That gave me a lot of credit space early on to do what I wanted, which to me meant I'm going to make myself suffer a lot and take a physics minor. So my first class with that was Modern Physics 1, my winter quarter. And so that just really takes you into the intro into, all right, what is physics since Newton, essentially? So you start out with a lot of Einsteinian concepts, like talking about relativity, special relativity, and then getting finally into some barely some quantum stuff when you define the orbit of an electron around a hydrogen atom. That was some wacky math. Not a huge fan of that. That's not why I wanted a physics minor. But in all of that, I made the decision that I wanted to pursue a career in nuclear fusion. And so that has kept me on my path to where I am now. My first summer, I was an intern at Janicki Industries up in Washington, where I worked on the plant floor in the mold fab. I was working with a lot of composites. The second summer, I went through the Department of Energy and got an internship called the Science Undergraduate Laboratory Internships at General Atomics down in San Diego, where I worked in the Inertial Fusion Technologies Department and created a capsule fill tube assembly station for the company in their microassembly lab, taking inspiration from their original ones that were up in the clean room. That then, through networking as well, ended up netting me my internship this past summer with Lawrence Livermore National Laboratories. I originally was slated to be also in their target fab department, so working with similar systems as to what I did at General Atomics, but unfortunately my mentor passed away about 5 days before I was supposed to start work. So I was reassigned to a new mentor, and I was in the X-ray spectrometry department, so basically where they use X-rays, which is a high energy form of light, to analyze the reaction that goes on when over 100 laser beams are fired at the capsule in the center of the National Ignition Facility. And so that reaction occurs on a time frame of way farther than less than a second. So you need something that operates on that time scale, and X-rays work great. And so what I was doing is I redesigned a vacuum tank that calibrates those tools that take the measurements. So that's as far as where I am academically, and if you have questions and you want to ask me about anything like that, please afterwards. But as to the purpose that Rob asked me to speak here, why and how do I still keep my faith with pursuing a STEM degree and also pursuing higher level physics? So, I mean, growing up, I was homeschooled until 7th grade, but in that I was able to delve myself into apologetics and also different forms of pursuing how does my faith meet science? I've always had kind of a passion for that. So I read books or watched shows, documentaries, stuff by Lee Strobel, like Case for the Creator. I'm sure you've all at least heard of that, maybe. I don't know. Anyways, he was a journalist who ended up writing basically a proof system for how can there, through science, be a logical basis to say there is a creator. Not necessarily that it is God, that is why there's a thing called faith. But the fact that when you look at science, you can step away and rest assured that your faith is not on sand, it's on solid ground. So for me, I'd like to start a little bit with just kind of the overall genres of science or focuses within scientific fields as they pertain to what we see. And so I'd like to start with astrophysics and a little bit of cosmology. And so a lot of that has to do with observations of what goes on just in the expansion of the universe and the light shifts and how stars orbit and planets are formed, but also it goes back to basically proving the Big Bang. The Big Bang has been something that evolutionists and also atheists have tried to use as a way to disprove Christianity and other forms of religion as not being possible. But they end up also running into the same issue that requires faith in the first place. When you go back to the start of it all, when you have that single point of matter, the size of what they say an eye, the dot of an eye, it's this concentrated matter and energy that just appears. Well, that breaks every single conservation law that they have, conservation of mass, conservation of energy. Like also the fact that it breaks, it's not a law, this one's not a law, it's a theory of entropy, but basically we haven't observed anything that reverses it. Basically everything tends towards disorder. And on a system as a whole, if you look at the universe, entropy is never reversed. Now, if you look in a freezer, you can reverse entropy, but the entropy of the room surrounding it actually increases, because what's happening is as you use energy to pull energy out of this system, it's not perfectly efficient in transferring in that process of getting the energy out. So energy is lost as heat into the surrounding environment as it also pulls the heat energy out of the stuff in the freezer. So you now have, for that price that you paid to get the heat out, you have additional entropy introduced into the system around you. So really, you just need to define where your boundaries of the system are when you're looking at entropy. And if you look at the universe as a net sum, entropy is always increasing. And for me, the Big Bang has been proven that everything originated from a single point. The science points to that. I fully believe it. Now, how did that point come into being? There's multiple theories as to a magical printer that keeps printing out universes until the dials are spun just right to get the physics to work out for this universe. Because this universe, I read in a book on string theory by Brian Greene called, I just blanked on the name, but with the Elegant Universe, yeah, there you go, thank you. If you messed with a gravitational or electromagnetic constant of how charges, positive and negative charges, interact even to many places past the zero, this universe would not function the way it does. Everything is very, very, very precisely tuned. And so with that, the Big Bang, what came before it? What made it start? Well, it's as much of a leap of faith to say that it was just happened as to say that a being outside of our laws of science brought it into being. And something I'd like to get into a little bit with that string theory is just a concept that I really, really enjoy. And so while string theory is not proven, I do find it a beautiful concept. Because if you start to look at life on the macro scale, you just see everything around you as it is, the human part, the biological, and then the matter. But when you go small enough, you'll find your atoms. And when you go smaller, you'll find your subatomic particles, your protons, your neutrons, and your electrons. Well, you can keep going. Below those are quarks. Those are, usually you have up, down, left, right, happy, and sad. I think it was probably 5 a.m. on their 10th cup of coffee when they named these things. But regardless, there's quarks that make up even those what we, usually thought were the smallest parts of matter. The theory of string theory is that below that, there's one more step of a particle. And that particle is called a string, hence the name string theory. And what I find so beautiful about this is in every single subatomic particle, quarks, and also your gravitrons and your Higgs bosons and all these other wacky particles that are in the universe that mitigate the different forces and interact with each other to present the universe we see, is made up of a string. And the difference is each string is vibrating in a different pattern and at different energy levels. That is what determines what particle it makes. And so what you see around you when you speak, when you talk, is vibration that moves through air. It is, yeah, vibrations. I don't know quite what else to say for that. But the idea of that, since the universe came from a single point, and if you go back into Genesis, God spoke. And a mouth, to me, is a single point of origin. And out of it came the vibrating energy of the universe you see around us. The world is literally vibrating with the voice of God. So that's it for at least the Big Bang part of it. And then I'll move on to like the formation of the planet and the creation of life. So whether you choose to say that Earth took billions of years or a day to make, I believe in a day, because if God can create something out of nothing, he can shift time scales however he wants. He created time. But regardless, the planet was formed, and there's, a bunch of different theories about early Earth atmospheres, like what it was made up of, how much water was here, different energy levels, temperatures, everything. And there's multiple experiments that basically they tried to prove that in those early conditions, amino acids could be created. And a couple of those experiments, they proved that it could be created. One problem, it also created cyanide. Kind of not good for life, just a little bit. But beyond that, they have also determined that those experiments that they did, I don't remember, a couple decades ago at least, they no longer think the Earth was made up of those elements in those concentrations. But with that, if you're able to get amino acids, there's 21 amino acids, 7 are essential to life. Each protein chain is made up of multiple, if not hundreds, of amino acids. And so on top of that, a single protein, there's hundreds, if not, I don't remember the exact numbers, but I think it's like millions inside of a single living cell. Each one has to be folded in an exactly precise way, usually done by a specific organelle within that cell. And then on top of that, you have to have DNA, which is the information that is what encodes how a protein is made, which amino acids go in what order, and exactly how it's folded. And what they want us to believe is that in the early Earth atmosphere, not only did enough amino acids get created randomly, they fell together randomly in the exact pattern to create the needed proteins, and then those proteins folded themselves in the proper format, that they were able to create the proper structures that could be connected to create the first cell membrane. And not only that, the DNA itself, or RNA, whatever you want to believe, itself fell together. This complex information that governs exactly how every cell functions and the complexity of life that you see before you with all the animal kingdoms, all the different abilities, like it's so vast, so broad, and so complex that there's this idea called irreducible complexity. And so irreducible complexity is basically saying that if you're missing one component of this functioning organelle or cell system, it won't work. But yet evolutionists claim that small changes across long periods of time created the diversity of life we now see. But getting back to that original first cell, if you want to try to run numbers on the probability that enough amino acids fell together to create enough proteins, to create enough, like a long enough strand of DNA that it can continue to live and reproduce, okay, it happened. We've got time. But nowadays, if you take a cell, you put it into a test tube at the perfect temperature with plenty of food so that cell can eat, reproduce, and live without any impediments. If you take a needle and puncture the cell wall of that cell, the cell can't put itself back together. How then am I supposed to believe that in the beginning, when the conditions weren't as perfect, when there was so much other probability going into it, a cell was able to form by itself? This isn't like a concrete proof. There can be arguments for it, but I find a lot of rest in that fact. As we go on to macro and then microevolution, there is a distinction. So I believe in microevolution. That's the difference between a horse and a pony, a lion and a house cat. It's basically variations within species. Completely plausible, and we see evidence of it around us constantly. Macroevolution, as I said, with irreducible complexity, I do not believe is possible. One, there's no evidence, and two, I believe that it takes away from the beauty, the awe, and the glory that God is owed for creating this universe. Basically, we are saying that God just started a planet and then let us randomly get created. The God of this universe loves us so much that I don't think he took chances with this world and who we are. I strongly believe that he intelligently designed and created every single living being. It was not chance. Beyond that, I mean, I'm not sure exactly what to talk about science-wise to go into to continue to, expound upon. Those are the main three. It's like, what is, evolution? So life that can change and be created without God, the start of life itself, and the start of the universe are usually the three main questions where people who don't hold a faith will try to counter someone who does. So I don't, how much
That was good. Good.
time was that? I can keep talking if you want, but
do you have any problems in the class with your classmates or professors?
I have not had any problems in my classroom with my professors, usually just because no one asks and there's no time to really bring up those discussions usually. You're taking notes the entire lecture. So really the time that you would have to have those conversations is when you're studying with students outside of class. Now I've had some of those discussions with students outside of class. I've not had any with my professors. I usually don't go to that many office hours and take the time to get to know a professor very well. There's only one that I did, Professor Eccles. He taught me modern physics too. But yeah, I haven't had too much of an issue. People usually, in all my experiences, I don't treat people or belittle them for not having a faith or for like how they live. And I just genuinely try to be kind. And out of that, they usually, when they find out I'm a Christian, they respect me for it because I don't push them away for who they are. I just love on them where they're at.